owner of a high-rise hotel in Los Angeles asked the architect design firm to do a study on the structural material of the hotel. They had three layouts for the hotel, and they wanted to figure out whether they should build the structure with steel, timber, or reinforced concrete. So the owner gave them 6 months, and in total, they had three different layouts and three different materials. So they had 9 different combinations, and they had 6 months to do it. So the owner wanted to figure out which one is the most economical one. The design team selected one layout and sent it to the external structural design consultant to design the structure of the building. After 2 months, they received the structural design and sent it to the estimating company to do the cost estimation. And the cost estimating company also took another 2 months. So after 4 months, they could come up with the cost of one design out of 9 different combinations that they had. So the question is, what if we could reduce the time of a structural design and cost estimation from 4 months, maybe to 4 minutes, or to 4 days, or 4 seconds? This way, when an architect designs the layout of the building, or even before that phase, when they do the feasibility studies, these AI models can give quick feedback to the architect about the structural performance and the cost of the building. This way, the owner and the architect don't need to wait for 4 months to know how much the structure would cost. So to sum up, by providing enough examples of inputs and outputs, the AI system learns the function and the process that connects the input to the output, and when the new structural design comes in, it can quickly calculate the output, which is the building performance. So let's talk about the 5 V's of data. In terms of volume, perhaps you need 3 to 4,000 data points. In terms of velocity, you need to create it once and you can reuse them. In terms of variety, you need to make it in a tabular form. And if you haven't done 4,000 projects before, you need to create a synthetic data set. The veracity really depends on the similarity and the diversity of the data set you create with the real world buildings that the AI system will be used for. And this way it can bring a lot of value to your company in terms of being able to do simulation really quickly. In terms of AI systems interaction, it is level 2 because AI can give the recommendation and the structural engineer can make final decisions. This way, a structural engineer is in charge of making decisions and it uses the recommendation of the AI system. So in terms of AI system limitations, there are three things: causation, counterfactuals, and constraints. And this is true for all AI systems. In this case, the structural design example, you need to make sure that most of the important variables that impact the performance of the building, that impact the output, are presented in your data set. Because if they're not presented, then as those variables are changing, you may not get the good results, even though you receive high accuracy in the output, but that shows only the correlation. So you need to make sure that you are considering all the things that impact the output. In terms of counterfactuals, if your dataset has examples for mid-rise buildings up to 12 stories, you cannot use the model that you create for buildings with 20 stories. So the results of such predictions won't be accurate because they're not represented in your dataset. And similarly, if you create an example with a structure with the maximum length and width of 100 feet or 30 meters, you cannot use this AI system for a structure with 90 meters or 300 feet length and width. And in terms of the constraint, that AI system cannot constrain themselves into finding the best solution for you. So the benefits of this AI system for the client is reducing the design and estimation time from 4 months to a few days, reducing the project costs because now you have all data that you need to make the most economical decision, and again making informed decision about the material of the structure.